Hey, everybody. Thank you for tuning in to today's episode of What's New in Data. I'm super excited about our guest, Jacopo Tagliabue. Jacopo, how are you doing today?
Very well. Thanks so much for having me. Thanks so much, everybody, for tuning in. And, 10 out of 10 on pronunciation of my name. So amazing work there.
Of course, names are important you know, and especially the pronunciation. And so you just launched a product, a really exciting announcement. As of the week of recording this, you announced your $7.5 million seed round and a lot of excitement about, what you're working on. But first, Jacopo, tell the listeners about yourself.
Yeah. So I'm Jacopo. I'm the CTO and co-founder of Bauplan. I'm also a adjunct professor of machine learning system at New York University, which is mostly notable because the only job I ever had that my parents understand. And I've been building a data and AI system for the best part of the last 10 years at any possible scale, literally from garage scale to IPO scale and everything in between, which makes me an expert because I made all the possible mistakes that somebody can make in the process of kind of moving it around.
Yeah. And that's really how you learn. I always say to own something is to break it first and then put it back together. And yeah, but the work you're doing is pretty exciting. You also published a great paper, and I wanted to get into some of the topics there. First, it would be great to just dive into some of the conceptual ideas that would be useful for the listeners. The first being FAS, functions as a service. Can you break that down for us?
Yes, of course. So Bauplan is basically the combination of two ideas. One is function as a service for data, and one is like Git for data, which, it should be more familiar because everybody knows what Git is. So function as a service is a paradigm of computation that is can be traced back to AWS Lambda, which is an incredible service. Has been like a lot of success and it's been replicated in other clouds like Azure Functions. There's a bunch of open source projects doing that, like OpenWhisk, Knative, just to mention a few. And what is the idea? So imagine the history of the cloud. So initially you have virtual machine. So somebody else provisioned the hardware for you and you do the rest. And then you have containers. So somebody else provisioned the hardware and the virtual machine. Sorry, I have a gigantic cat that is throwing stuff. So the sound that you hear is this gigantic cat that throws stuff down now.
Very
Yeah.
cute. Yeah, great cameo from the cat. And obviously wanted to chime in on functions as a service.
Exactly. So they have containers, and containers, somebody else provisions the hardware, the virtual machine, and then you just do the thing on top, like imagine stacking this. The last layer of abstraction, it's like serverless functions, which is somebody provisioned the hardware, the virtual machine, the Docker containers, and you just literally send a function for somebody to again, typically it's AWS Lambda. And that paradigm is awesome for all the use cases in which you don't want to think about the underlying infrastructure, maintenance, scalability, and all of that, and you just want to write your code, which I believe, at least as a user, is a very powerful abstractions because I want to deal with the business logic and with, wrangling my data. I don't want to deal with, Kubernetes or containers kind of bullshit type of thing.
Yeah, and that can really slow teams down, right? When they have to think about the infrastructure and how to provision it and how to deploy it just in time for certain workloads or continuously have it running. So I want to get into, how does this differentiate from something like a Lambda or an Azure Functions?
Yeah, so I think originally sorry, one sec. Yes, my VP of engineering. Originally, the use cases for Lambdas, which have been enormously successful, were microservices. So can you respond like hundreds of milliseconds responses that you may want to scale horizontally. Let's say you have an endpoint that produce some analytics results, like, like a pixel for advertising. That would be a fantastic case for Lambdas. Actually, my previous company did that in 2018. We were probably maybe one of the first people on the planet to try that. It's an amazing use case, like 100 lines of code, AWS spins it up, gives you the result back in 100 milliseconds. If you have more requests in parallel, they just scale it for you. That's amazing. Okay. But that's exactly the opposite of what you need for data. So data functions are bulky. They run for minutes, sometimes for hours. and they don't really get you back things. Like the typical data pipeline will not get you back things after one function, but it's a combination of functions. You build a DAG, if you imagine, a chain of function. And so the question becomes, how do you pass data between one function and the other more than how you get a JSON back from a 100-millisecond request? So while the ergonomics of serverless Lambda and serverless Bauplan are similar, you build a function, we do everything else, the actual underlying system is completely different, which is why we have to build our own runtime to solve this problem, because we couldn't reuse any of the existing solutions in that time.
So Bauplan combines the programming model and the runtime, which is very unique. And what is it that makes it specifically very good for data pipelines?
Yeah, that was like a weird choice. So in the very beginning, we started with testing out open source implementation for functions, like OpenWhisk. We know a bunch of people that actually had a good fortune with that, Knative and all of that. But they were all limited in one way or the other, because the thing they were good at were use cases we wouldn't care about. And the thing that we needed were not just represented there. So we decided to build our own. And we always say we built Bauplan because we couldn't add data to Lambdas. And on the other side, we were not really able to add like a runtime to an orchestrator. Like if you imagine there are very famous popular Python packages for doing DAGs, Airflow, Playfake, Dagster, and all of that. But they're a framework, like they're a way in which you express your thoughts. They don't really run the compute for you. They don't optimize the compute for you and all of that. So Bauplan is the combination of these two things. So we co-design a very lightweight framework for DAG. So you put a bunch of decorators on top of your function, and that's kind of it. So very lightweight compared to Airflow, for example. And then we designed the runtime that somehow leverage this way of expressing things to run things as fast as possible, as efficient as possible, as cheap as possible. And looking back, what was kind of a crazy idea like 18 months ago, now it kind of makes sense. Because if I work in Bauplan today, it wouldn't be as nice if we decided to not do one of the two, in a sense.
Yeah, because you have like you said, it's, you have the compute engine with a really convenient Python programming model, right? And when you combine those two things, it definitely allows developers to move much faster, just having everything included.
Yeah, I think, the operating, design assumption of Bauplan is, if I can't explain this to my students at NYU, there's something wrong. You know what I mean? And, my students are great for, along many dimensions, but they're not senior software engineers. They know what a package is, but they may not know what Docker is. They know what a table is, but they definitely don't know what Apache Iceberg is. Like, definitely don't know about that. They know what an endpoint is, but they don't know what Apache, Arrow flight is. So the platform exposes all of this in a way that a student at NYU can understand. And it does all the hard work of kind of like making the infrastructure works behind the scene.
And that's very cool. I mean, you named some frameworks there. Let's get into one of them, since I know you're using Apache Arrow, which is a popular in-memory serialization format. It's used by Spark. It's used by Pandas. Many frameworks rely on it. How is Bauplan leveraging it?
So there's a few things there. So the first thing is that, remember what I said before, when you consider
the cat has a lot of things to say about Arrow.
It's just incredible. The cat didn't say anything for the entire day before this. So it just, it's like an incredible cat. Incredible timing, Maton.
Yeah.
So the problem with pipelines is as follows. When you run a microservice, you activate a function, and that's independent of all the other functions. That's what makes microservices so great, right? But that's not what you really do with data. Like, data pipelines are a combination of functions. Imagine a machine learning model. You want to clean the data, you want to aggregate the data, you want to maybe produce 3 different data sets to then serve it to an OpenAI endpoint, right? And this is a DAG. So it means that the result of one function needs to go into the input as a function afterwards. If you do this naively, XCOM in Airflow, Wink, or with Lambdas, you need to go and serialize back to object storage all the time. means you need to take these hundreds of millions of rows potentially, like pay the price of serialization, compression, whatever, write to S3, and then a function next to it, you need to do the same process in the reverse. Now imagine a world in which we don't pay any of this. Imagine a world in which if we don't have to go to S3 because we actually want to save this intermediate result, we can either collocate the two functions, and Arrow allows you to do zero copy between them. So the parent function output a table, and then all the children can read without copying the data, which is amazing. Imagine when you have like 10 fan-out functions, and the total amount of memory you use is one table, instead of like 10, which would be the naive use cases. Or if you are across machine, across host, this function can communicate through arrow flight, which is the same arrow format that we use in memory, but sends over the network. The good thing about that is that you're not going to pay the serialization cost. And so since the functions are already in ET2s, you get the bandwidth of the cloud. It takes less time to send an arrow flight between two machines co-located in AWS than to read the same file from a disk in Parquet into the memory of a system. That's how much serialization actually is a penalty, is a tax when you do these type of things. So going back, imagine we're doing this for like a DAG with 15 functions. The difference between the naive way and the Bauplan way may pile up to be, 10x faster at the end of the day because of these choices.
Yeah, and that definitely makes sense because if you have a DAG, these sort of, dependent processing components, right? It doesn't make sense to store the data, write it back to S3 between each intermediate step and then ingest it again and process it. So it sounds like you're efficiently using Apache Arrow, which is, all in memory, a very efficient format as your kind of the data transfer between each individual component in the DAG.
Yeah, like it's been a bet. We bet on a few open formats when we started this, the other one in being Iceberg. So memory, the conceptual distinction is like memory and over the wire is Apache Arrow. On disk is basically Parquet and Apache Iceberg. On disk is meaning, of course, object storage. And there hasn't been very good bets. If I look back 18 months ago, these two ecosystems were already growing, but not nearly enough as they are today. Now, Apache Iceberg is the de facto standard for lakehouse formats, I would say, probably. I mean, at least the most popular one of the three major ones. And Apache Arrow is definitely catching on in many more languages and even more databases. There's like a lot of companies now building on Arrow as this kind of like, standard format for interchanging data between systems. So those bets have paid off massively, especially for a small company like us. We can't reinvent everything. We have the spare parts manifesto that we published like at the very beginning of this company of like, how can we build a lakehouse with so few resources? And the reason is that, you are just to be a bit clever in reusing some stuff that is already there and deciding what you want to actually build for yourself.
There's a lot of great components out there, like open source components, serialization formats, table formats, Parquet, and then I think the industry has matured to the point where people know what works and what doesn't, just from a practical perspective. So it seems like you really did combine a lot of the best elements there into a product that's super, super honestly ergonomic is what I would call it for data engineers and developers. You wrote a paper, Bauplan, zero copy, scale up fast for data pipelines. It's a great paper. I recommend reading it. We'll have a link to it in the show notes for the listeners. But there's one point you mentioned there, which I kind of latched onto, which is that it feels local when you're developing with Bauplan. Tell me about that.
So there's this thing, the developer loop that software engineers are used to. Like, they have a small part of code they can test it locally. Imagine like a Python developer can like a PyTest with some mock data, and it's kind of very fast. You can do TDD. You can do all sorts of fancy things when the time between the thinking and the actual proof that things are working is very short, right? In data, imagine now, take this and go to data. Now you may have, a Spark cluster. You have to wait 5 minutes for that to be available. When there's a stack trace of an error is like 35 lines of Scala that you may or may not know how to read. We have all been there PySpark. And then when things go well and you need to move to I don't know, to another versions of pandas, now you have to redeploy the entire cluster, hope it doesn't break, and then do this again. So if you take an hour of work, you code for, I don't know, 25 minutes, and the rest of it is waiting for things to happen in the cloud, which I think has been the default cloud experience for data people in the last 10 years. So what can we do to compress this time to seconds, to be as close as your local development feedback, or even faster in the case of Bauplan? And so that has been a guiding principle for us. It's like, it needs to feel like local, meaning, for example, if there's a print statement in any function you write, you're gonna see it in your, in your terminal, like it was a print statement in your normal code, and needs to be very fast. Like adding a dependency to Bauplan. Let's say you move from pandas 1.5, you move to pandas 2.2, and then you do Bauplan run again. We are 15 times faster than Lambdas and 7 times faster than Snowpark at that particular operation, which again, may not mean a lot, but if you combine how many times you install or try new packages when developing a pipeline, this kind of piles up to quite some times. And we're very happy with the idea that people don't have to wait too much to get to know if what they did makes sense or not.
Yeah, and you're seeing more data processing engines emphasize the local experience. So DuckDB is very popular. There's Apache Data Fusion, and there's definitely this movement behind it. And it totally makes sense because we might as well leverage the power of our laptops if we're doing some client side filtration or ad hoc analysis of data. But it's also just more portable and makes it so that not all your compute and information retrieval has to go through some managed service in the cloud. But then if you want to at a certain amount of scale, that's also useful. So it's really giving developers the best of both worlds.
Yeah, we're very grateful to the community. Good friends with many people in Data Fusion. We use a fork version of DuckDB. We have some blog posts on that for the engineering
Cool.
geeks. And so we're very grateful for the work they put out. The choice that we made with Bauplan is once you work with data at a certain scale, like, tens of millions, hundreds of millions of rows, a gigantic bottleneck you're going to have is bandwidth, and it's very hard to beat S3 to EC2. So a lot of our work in making the cloud feels like it's local will result in actually a faster feedback loop than just spinning up DuckDB on your machine, just because there's such a difference between your bandwidth and the one in the cloud that is very hard to be competitive in that sense. But on the other side, we didn't want to have the cloud experience that you get with EMR. Like, yeah, there's a cluster somewhere. Again, it's mostly me waiting for something to happen, and it kind of looks like a black box. So finding the right balance between these two forces has been probably one of the hardest things that we did in the first year. It's not really an engineer, it's the between engineering, product, API, it's kind of the intersection of like human machine design and the actual tech. But these are details that are surprisingly hard to get right.
Yeah. And since you brought that up, I just came across this. You have a blog, Blending DuckDB and Iceberg for Optimal Cloud OLAP. Lessons learned crafting a service lakehouse from spare parts, like you mentioned. So I'd love to get into, that blog, what you talk about there, and how you kind of combine, parts of DuckDB for the compute and then Iceberg as your storage.
Yeah. So, now the community has evolved a lot in the last 18 months. And now there's a few extensions that has been proposed to do DuckDB and Iceberg. But when we started, none of that was a thing. I think it was DuckDB 0.6 or something like that. So I think we're like 1.2 now. But what was the general, what is the philosophical idea of Bauplan? Again, Bauplan is functions as a service, and these functions do not exist until you ask for them, including SQL queries. Like, one of the weirdest and most distinctive thing about Bauplan is that you can open your terminal if you have pip installed Bauplan before, and you can do Bauplan query, select, sex count from Titanic dataset, group by sex, and then you press a button, and that will run a SQL query and visualize the result on your CLI like it's a warehouse. But what is the magic trick? There's no warehouse. Actually, there's nothing before you press enter. So when you press enter, the SQL query gets parsed by our custom parser. We understand that Titanic is part of your iceberg catalog tables. We go from the Titanic iceberg table to the underlying Parquet file of the snapshot that we need. We launch a function with DAGDB as the memory engine that processes this data in memory and then sends you back to Arrow Flight the results. All of this happens on demand. When the Arrow Flight sends you data, it dies because nothing in Bauplan exists for more than the span that it needs to do for compute, because it needs to leave room for other functions to run. So even when you run a function in Bauplan, it feels like you have a warehouse. But what actually happens is there's an ephemeral DuckDB engine that just spawns up, answers the query, and then dies. And then a new one is going to spin up once again, if that makes sense. And to build all of this with combination of fast iceberg, S3, and blah, 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 at that time, we had to, get our own parser and all of that, which is with the journey that we detail in our blog post for the community to learn from as well.
Absolutely. And is every component in your DAG like its own instance of DuckDB?
Every function in the DAG is a fully separate containerized function, including the SQL one. So when you can chain SQL and Python together, and you can even have weird things like, I want to run 3 functions in Python 3.10, 2 functions in Python 3.12, and 3 different versions of pandas. And this will all work because functions are really, ephemeral and, separate on the environment side, which again, think about Spark. You can't run half of your Spark cluster in Pandas 2.2 and Pandas 1.5, while the idea of using function as a smaller compute block gives you the flexibility to pick and choose. So if you want to update some of your function to Pandas 2, but leave some of them to Pandas 1, be my guest. Like, the DAG will work either way.
Yeah, that's definitely a super interesting design. I'm glad that we've covered some of the fundamentals here and how the DAGs work and what the underlying components are. Tell me how it scales. Like, what is your methodology to, increase both the throughput and even the availability of your workloads?
Yeah, so that's a very good question. And so there's the first, which is, our hypothesis when going to market based on, years in this space. We call it the reasonable scale hypothesis. It was like back in the machine learning days. And it was based on our observation that back in the time, many people wanted to use distributed system to do training in that particular instance. But it turns out that dataset didn't grow as much as compute in the same amount of time, right? When Spark was started, a typical ET2 machine would be smaller than an AWS Lambda today. Yeah, it's a fun fact that you can Google, which of course, again, is not the world we live today. Now a Lambda has 10 gigabytes of data in memory, and you can find EC2s with a terabytes of RAM, just glitch it off the shelf. You don't have to do many things. So the system that we design has been based on the idea that function will run on one host and one host only, meaning that you can have a DAG of 15 functions. Some of these functions may run on different machine, but any given function is a single, basically, process type of thing. And again, thanks to our friends in DuckDB, Data Fusion, Polars, and all the great work that the community has been doing in single node processing, this would not have been possible 10 years ago. So this is kind of like the first point. How do we scale? We scale basically with our own scheduler. So when you submit a job to Bauplan, it goes to a control plane that is linked to your account as an enterprise. So all of our workers are single tenant, SOC 2 compliant, private link, you name it, so that everybody is happy that the data doesn't go outside. And then the control plane checks, if there's availability in the available workers. If yes, it just sends what we call the physical plan, which is the actual thing you need to run to make the DAG work to the worker, and the worker has his own binary, which is our custom runtime to, spin up the container and do all the jazz that we described. And then, of course, it may be that there's no available space. And so one of these two things happen. One is priority-based scheduling. So if you're submitting a query, that's typically considered a synchronous operation because there's a human on the other side. So it may be that we want to pause an existing DAG in between function to serve a query and then resume the DAG, or we spin up new workers. And in that case, you basically just augment the total capacity at your disposal. And that's the easier way to schedule. But that's our really last resort. What, our attempt is always to fit within the given capacity with provision as many workloads as we can. Based on the observation, I think it was the Borg paper by Google also did that. Mesos. There's a bunch of people in the system community that have observed this before, that you get much higher utilization by combining synchronous and asynchronous workloads instead of having two separate paths for batch and real time. Because nobody will ever fill the total real time capacity, which leaves you a lot of spare room for things that are less time sensitive to be processed efficiently. And I think that's kind of like one of our basic system intuition we're building Bauplan with this one.
And are there ways you can implement, let's say, partitions of data, or sharding different data across different components of the DAG? How does that work?
So right now you cannot. Right now functions are literally bound by the host in which it gets scheduled. You could imagine though that for, let's say, embarrassing parallel operations, say you have a data set and there's an operation you want to do on every month of this year. Okay, you can totally imagine it's a relatively trivial thing to do, to have a new decorator on the platform that says shard by month, and then the child function, instead of running once, runs one copy for each of the 12, and then you're going to get back to the general problem of scheduling. So the good thing and the bad thing about this is that since everything is a function in our lakehouse, there's always one mental model to learn. The user just need to basically pile up functions, and we as developer, we just need to schedule function efficiently, which again, very different than your typical lakehouse when you have notebook clusters, warehouses, orchestrate, like, you know what I mean? To do the job of a lakehouse, most people cobble together 10 different systems, 12 AWS tools. Bauplan is this kind of weird idea that a lakehouse is just basically a combination of function with different priorities. So some of those are very important when you run a query. Some of those can wait a bit. If a pipeline typically runs in an hour or 5 minutes, it's really not that important in most cases. And so that is akin the intuition. So we pay the price of, some scheduling penalty for simplicity, uniformity in how the system is actually run.
Yeah, that's super impressive. And, it's clearly a very flexible framework, but scalable at the same time. I'd love to get into, the core use cases that, you're solving. We all know that that data processing can be pretty, general in the types of problems it can solve. But what do you see as like the key popular use cases to begin with?
So our customer right now are mostly exploiting the platform in 3 different ways. One is write audit publish pattern. For people that are not familiar with this whole idea in the data lake, that instead of adding new rows to your table and then figure out later they were bad rows, what you do is that you use branches like you would do with Get. You import your new data into these branches, which is separate from the main system that everybody see. You do a quality check, and then if the quality check passes, you merge it, and now it becomes the new production data. If you're familiar with CI/CD, it's exactly the same thing, but for data. Bauplan allows you to do this with 2 lines of code, and it's super seamless to do. So that's been very popular. General ETL pipelines for analytics. I mean, boring these days because everybody wants to do AI, but it's also being a staple for our customer. Moving data from point A to point B to power a dashboard for executives. Again, of course, there's many other tools you can use, but it's hard to find a tool that is as simple as, and kind of like straightforward to use as Bauplan. So there's been a very popular use cases. And finally, unfortunately or fortunately, the old Gen AI app is taking everybody by storm. So there's always some new use cases about Gen AI that, our customer want to leverage. The typical use case in data pipelines and AI is data enrichment. So you get data from a stream. Let's say you're an e-commerce, just to make an example. You get catalog data and you want to produce a new description of your products based on some marketing idea. like market this to a Gen Z person living in Williamsburg. And for this thing, Gen AI is actually very good. So what our customer do, they just import whatever package they want for, I don't know, OpenAI or Bedrock or whatever they want. And then inside of the data pipeline, they will basically insert Gen AI capabilities, leveraging the rest of the components that Bauplan gives you, branching, versioning, Iceberg compatibility and all of that. So these are kind of like, we say, the three main things. So engineering, WAP, analytics people, ETL, and, AI, machine learning people, AI enrichment type of thing.
Yeah, it's, I think just the flexibility and just how, you combine the programming model and a pretty flexible runtime opens up a lot of use cases like the ones you mentioned, you know, specifically with the, generative AI, what do you see as like the best practices like in your pipelines for interfacing, let's say with like a OpenAI or an Anthropic model?
So there's a few things that I think are key in the new Gen AI world. One thing is you want to experiment a lot. At least that's my experience. Like I'm still very bad at prompting, and I think that's, it's no shame in admitting that. So it takes me a while to get the right thing. And also I find that the same prompt perform wildly different across models. Perhaps I'm not the only person that thinks that. So a good thing about Bauplan is that you don't have to really choose. You can set up your pipeline accepting a parameters that you can just feed at runtime that, for example, says, hey, use model A or model B. And then you can just script it to produce, the same pipeline, the same code, starting from the same data lake, but producing branches that produce different versions of your target table. That's very powerful because you can say, hey, how does this prompt look with Anthropic? How does this prompt look with OpenAI? Or switch it up. How does, you switch the prompt, but you keep the OpenAI model the same. And then you get all these tables, which are versioned for you in object storage automatically by Bauplan. And then you can build, I don't know, a Streamlit app for your colleagues in Python and say, hey, these are 3 different models, 3 different branches. Which one you like the most? And when you say this one, you know what you do? Bauplan merge, and that branch become the production branch. And again, you start to reproduce the pull request flow, but for Gen AI, which I think is very powerful in a sense, especially when you can do it with like 3 lines of code.
Yeah, very cool. And, there's, people are writing DAGs today. They're using things like Airflow or DBT. What would you say to those teams? Would you say migrate or, use Bauplan for separate use cases? Like how should they think about Bauplan as like a choice for some of their development?
These are, if you take like DBT for it, like I think the answer is slightly different between the 2 examples. So if you take DBT, very good, especially for SQL people, is mostly, let's call it templating engine for DAG-based transformation. And we owe a lot, we as a Bauplan, the community, to some of the very good ideas that the DBT team had back in the days. If you want to keep the code in DBT, but runs on Bauplan, that's fine. I mean, transpiling that code to our platform. We didn't have a customer that had this need yet, but it's obviously something that can be done. So if somebody has a preference for the DBT style of syntax and not the Bauplan one, I don't think that's a particular issue. For orchestration, though, I think the answer is a bit subtle. So we don't orchestrate things, meaning that if you want to run every day at 11 p.m., a Bauplan run, we don't do that. You have to do it yourself. That said, is one line of Python that you can import in any orchestrator of your choice. That was a design choice that we made explicitly because nobody wants to change orchestrator. That was our market. I don't know if you saw the same, John, in the market. But like in my experience, when somebody's an orchestrator, then they want to adopt a new one just to adopt a new data tool. And so the idea was that keep your orchestrator. We're not going to run this every day at 11. You are going to run this every day at 11, but I'm going to make it so trivial to run this from Airflow Prefect Dagster that you can't say no. And that's the choice that we made. So if you already have Airflow, my suggestion would be run the business logic of data in Bauplan, because it's a million times better than passing data between XCOM or, having a Kubernetes cluster to orchestrate Airflow. There's no comparison between these two. But keep Airflow for backsealing, observability, triggering and all of that. The difference that your Airflow DAGs will become one-liner. Like my best orchestrator code that I've ever seen in my life is every task is one line that codes an external service, and the orchestrator just basically does let's say, the outer loop of this, which I think is a very powerful thing because it leaves orchestrator to do what they do best, backstealing, triggering on time or events, and it leaves Bauplan or other tools, the example still stands for Databricks, for example, to do what they do best, which is process data. I think when people use business logic inside an orchestrator, that's where things get not super good. Because now you're constrained by the orchestrator, both runtime and syntax, for something that should be a bit more general. So that I don't think is a very good pattern. I don't know if that,
Yeah.
I've seen or
Yeah, definitely answers the question. And, I think that's, a lot of the subtlety is the design and the separation of concerns for, the data pipelines that teams are building. And ultimately it comes down to what their requirements are and what type of capacity they need and how they're even ingesting the data, whether it's, streaming data or data that's coming from an API where they can't pull it more, once a minute. And then going from there and really architecting something holistic. Now, I wanted to ask you, like every time folks working on a big project, like a big software engineering release, there's always some surprises, right? So I'd love to ask you, like, what was a moment during your development or testing or when you took it to users for the first time that something surprised you and it ultimately shaped the final design?
surprise me in a good way or in a bad way?
Let's do both. I mean, there's probably both. So
Yeah. So there's a few things that I'm happy to, and I'm definitely happy to elaborate. One thing that I would say though is that, our first company was about natural language processing when it was still not cool and it was still hard to do. And so we built data pipelines for like a long time. So the first real customer for this product was a younger version of myself, like slightly slimmer, no gray hair, slightly funnier. And so every time when we started developing this, we kind of ask ourselves what product we would like to have at our disposal when we built our first company. Instead of the stack that we end up doing, because that's what was available at the time, which was Airflow, EMR, and Glue, if people are curious. And I can talk about that for like hours and hours. So in the very beginning, design choices was mostly based on our taste, for good or bad. And then we started experimenting. I think it was like after 6 months of building with our first users. And the first surprise is way more people want to do Python than SQL in building data pipelines. So initially the tool is still SQL capable, but initially we were thinking there was like a half split between our user of using SQL in pipelines and Python. It turns out to be that at least for most of the people that we talk to, most of our customers, this is not true. Most of our customers use for the vast majority Python packages to do the transformation, and they use SQL just for the last layer to visualize data and look at or stream it or whatever. So some of the things that we built early on didn't turn out to be super useful. And I think now the platform is in balance in the other sense. Like a lot of attention goes on our side for Python workloads, and SQL is there, but it takes a bit of a backseat. Even if you go into the documents and the examples, they're now like, 85% Python heavy in that particular sense. I don't know if it's going to stay that way, but definitely a lot of pull that we're having from people building ETL for OpenAI or stuff like that kind of pulls us in that direction. So that things we didn't anticipate. And at least based on my experience, I love SQL. I love both. I love SQL and Python. So that was a bit of a change of mind. I think that surprised me positively, but we had a lunch about that, is the entire branching concept. People in SQL are very used to the idea that when you run a bunch of shit in Snowflake or whatever, it either runs or it doesn't. It's the concept of transactions, right? The database is, kind of like enforced for you, right? So it gives you kind of this peace of mind, that this thing, it's either okay and somebody downstream can read it, or it failed for whatever reasons. And, sure, it's not a good thing, but you can look into that. None of these exist in the Python pipeline world. Like, there's no such a concept in Airflow. Like, go back, if you build your entire business logic inside of Airflow, this concept is not, there's not such a concept in Airflow or S3 or XCOM, right? And so I think a very powerful thing we did was this concept of Git for data, in which we empower arbitrary pipeline or whatever language you want, SQL, Python, mesh together to be transactional. So if today you run a DAG of 10 minutes, have 15 nodes in Bauplan, they either complete, and so you're going to find the result of these tables in your branch, or they're not, but there's not going to be quantum state. There's going to be a superposition of half tables are wrong and half tables are correct. You either see the entire then, or you don't, which have been incredibly well received. I think Git for data, this whole idea that you can use Bauplan like you use Git. You do Bauplan branch, Bauplan checkout, Bauplan merge. This entire thing is the most popular thing on the platform right now. We do tens of thousands of merge a week between manual usage and, of course, scripted machine usage. So there's been a surprise in the positive sense. I think people find it very novel and kind of a fresh take on this whole concept of like running pipelines, but with some safety boxes.
And does this, so this supports like you said, it's like Git for data in a way. Is this versioning for the DAG runs and the data itself, or is it more for the logic?
The cool thing about having framework and runtime is that we can version two things at the same time. So those like data and code are inextrinsically, sorry, is that a word? No, I don't think it's that word. But like they cannot be dissolved, basically. So every time you run a Bauplan run, you run a pipeline, you get back an ID. That ID uniquely and immutably identify two things. The commits corresponding to the state of your data in that specific moment is the start of your pipeline, and the code that you ship to the cloud to run. What is the consequence? If a month later you come to me, John, and say, I had a bug in the pipeline, can we debug it? I don't have to go to CloudWatch. I don't have to open 40,000 tools. I don't even have to go to Git. You know what I do? I do Bauplan rerun, and I pass the job ID that you gave me, and I'm guaranteed that I'm going to run from the exact state of data with the same exact code that you did a month ago. So I can reproduce forever everything that happens in the platform. And that is only possible because we keep track of both things at the same time.
Yeah, that's super impressive and very well thought out, and really gives a lot of, flexibility and, a lot of room for, collaboration and experimentation with these pipelines. And another thing I wanted to ask you was, you have a strategy for kind of handling like the dependency isolation between functions in the same DAG. Like you said, you could run different, like you could hypothetically run different versions of Python. How do you manage environment provisioning for that?
Yeah, that has been a nice trick that we learned from our advisor, which is Professor Tyler from University of Madison, Wisconsin, which we have a collaboration. And so imagine what you need to have to run a Python process. There's going to be a Python interpreter, and there's going to be a bunch of packages, which at the end of the day are a folder in, next to the Python processes that you've been installed with pip. Okay. So the normal way in which people build a container is basically a requirement file with a list of packages, and then you're going to go and install one of them after the other, and then you run the process. What is good about this? It gives you isolation. You can run two functions with different containers. What is it bad about this? You need to reinstall all the things all the time because these two containers don't know about each other. So that's a naive way. So what did we do instead? So when you actually now ask Bauplan to run pandas, Bauplan first gets the dependency graph, the transitive closure of all the packages that you need for pandas. Okay. And then it's going to install each of them in parallel separately on the underlying host machines. Okay. So when you need to run a container, we do not do Docker build. We don't do pip install. We build a container and we read only the packages that you need in the environment that you need. This means that now we don't pay minutes of penalty to download packages or, duplicate them. There's at most always at most one copy of each package for each version. And so starting a container is basically just mounting folders, which is why our container starts in 100 milliseconds and not in 10 minutes. And so this way, you get to reuse basically everything that somebody on your team already used without paying the penalty. And since people that work in the same company tend to install the same packages, the cache hits are a lot. The cache is always very warm because everybody is installing basically the same packages, which makes all of this works very well. So the consequence of this is that our lifecycle management for the functions is straightforward. They go up, they run, and they die. Why? Because they're so fast to go up, because we don't pay any of the real price of building containers, that for us is much easier to reason about them if we just kill them all the time, instead of if we have to manage a life cycle of the container. So that's been kind of the trick there.
Yeah, and that's one of the things that's very impressive about Bauplan. There's a lot of great, you can call them technical tricks. You can call them just really great design choices that ultimately lead to, a really great developer experience and performance. I'd love to hear from you. Where can people continue to follow along with your work?
I mean, I'm very easy to reach, and as you probably guessed by now, I like to talk a lot. So I'm very social. I'm happy to take a coffee or virtual coffee with anybody that wants to geek out on any of these topics. So LinkedIn, email, whatever they want. If you want to, in particular, know what Bauplan is doing, we have a newsletter with, when we send out our blog posts on engineering stuff, our research paper. And of course, if you want to try the product, you can just sign up on the free sandbox. It's free. You can try it on public data set. We're always happy to get feedback. We're in private beta, so you need to send an invite and then we invite you for that. But again, we're in the process of being very open with what we're doing. And now that we have, production use cases that we feel very confident about. And so any feedback, even negative, especially negative, is very welcome. And again,
that's the valuable feedback.
That's the valuable feedback. That's the valuable feedback. And especially if you're a founder, especially if a young founder is a first-time founder, somebody did that with me, the first company. And I'm happy to give back and listen to you and give you unsolicited feedback on your company or fundraising or whatever. But seriously, if you're a founder, especially in data and AI space, and want to talk to somebody that's a bit older than you, or you think I can be helpful in any way, please do reach out, because I'm really, really happy to help the entrepreneurs, especially.
That's great, and great opportunity for the entrepreneurs in the AI space, and work with someone who teaches at NYU and has a lot of experience in this space. Jacopo, thank you so much for joining this episode of What's New in Data. I know at the time of recording this, we're in mid-April. I'll see you next week in the Data Council. We talked about bringing our tennis rackets. You can continue to work on your backhand volley a bit. I'll definitely target it. And
I'm ready to be destroyed by you, John. So at tennis.
No, you're just setting me up for a surprise loss. Yeah, sure. It'll be good times. Data Council, and you're giving a talk at Data Council as well, right?
Yeah, Bauplan, yeah. Chiro, so my co-founder and Chiro is going to give a talk on Python on the Lakehouse. So it's going to be more a talk on the, let's say, data science, the ergonomics of the platform, a bit less of the inner kind of like infrastructure stuff we went into today. But we've been around for the entire 3 days. So if you want to get, a coffee or a drink on our dime or on our investor dime, please reach out. We're super happy to meet interesting people. And again, we always love to talk to other founders and startup folks.
Awesome. Well, I'll post that on LinkedIn today, even though this episode won't be out before Data Council, but all in good timing either way, and look forward to seeing you out there.
Of course. Thanks so much for having me. Thanks everybody for tuning in, and look forward to play tennis with you, John, and everybody else who wants to challenge me at that.
Exactly. I mean, you're basically inviting it because your LinkedIn tagline is, that you're working on backhand volley. So of course, there's really no other choice than to play some tennis, hit to your backhand when you're at the net. It's a really great opportunity to work on it. That's one of my weaker shots as well.
You wouldn't guess how few not unsolicited requests from recruiters I got when I moved my tagline from AI data, whatever it was before, AI director or whatever, to, to improving my backend volley. And the number of requests that I get from recruiters dropped 98%. So at least there was something good that came from the tagline.
There you go.
Yeah.
Yeah. Yeah. Well, awesome. And look forward to see you next week. And thank you for joining us on this
Again,
episode. And thank you to all the listeners who tuned in.
thanks again.